Hey, afternoon, everyone.
Hello, Agus. Hello, Agustin. Hello, Sebas. And hello, Alpio Costa, our
Hello,
invitee.
everybody.
Hey, how's it going? Hello, everybody, and thank you for coming to this new icebreaker conversation, which is going to be amazing. And we are all nervous and silly looking. This is our first YouTube live, so we are excited that you guys are around. We can see some friends writing on the chat, which makes it awesome. So, everybody ready for this?
Yeah,
Yes.
let's go.
Yeah.
Let's go for it. As I mentioned, we have Alpio today to talk with us. Thank you so much because I know you're very busy. Alpio is a climatologist. I already have the first question. I want to know the difference between a climatologist and a meteorologist, if you can tell me that. But he's been working for a long time in Antarctica. We've been colleagues in the National Antarctic Direction in Argentina, and I'm really excited to have you here. How are you?
That's a good question because usually many people make confusion about this,
Mhm.
but specifically when you are talking about meteorology, you are talking about all processes that are more related with weather and with daily time scale. Instead, when you are speaking
Yeah.
about climatology, you are speaking or talking about processes related with another time scale, longer time scale, like years, for example. It's not the same to say what's the weather today and what's the climate in this place.
Perfect. Crystal Krill. Crystal Krill. Thank you for that. And what do plastics and microplastics have to do with this? What can you tell us about this?
Okay, microplastics is a growing concern issue. When our parents or grandparents were a child, they didn't use so much plastics. They
Mhm.
can tell us nowadays. And suddenly there was an explosion of plastic using over the world, like I think it was around the 70s, maybe. So that makes a problem and concerning, a growing concern about this problem, which is understudied. But usually, if you take a look on publications of microplastics over the world, you will not see so old papers or articles. It's a new issue, more or less new issue that it's growing over the world in many regions and also in many parts of the climate systems. I will say what's the climate system, what the climate system is. It's not just climate, but unfortunately, we see nowadays microplastics, and we are going to say now what are them in
Yeah.
everywhere, in water, in air, in stomach animal, in the stomach of the animals.
Mhm.
Unfortunately, everywhere.
Sure. Let's jump into it. You prepared a few slides for this, right?
Couldn't listen what you said. Could you repeat?
Yeah. You prepared a few slides for us, correct?
That's correct. That's
Yeah.
correct.
Sure. Go for it. So, what are microplastics then?
Lucia said, my name is Alfredo, but people told me they call me Alpio, so you can call me just Alpio. The only people who call me Alfredo were my parents when I was in travel when I was a child. So I prefer just Alpio. Okay.
Of course.
Yeah, so typical.
Yeah. So what are microplastics? That's the first question because we are talking about microplastics and you may have an idea, but we have to specifically define what are them, and then we can take a second question, why should we care about this? So the first thing to know is that plastics have many sizes. You have megaplastics, mesoplastics, microplastics, nanoplastics. We are going to focus on microplastics, which nanoplastics can also be included. Okay, you see in the graph on the right, you will see that the gray column agrees with the left graph. Okay, so you have larger particles or larger objects of plastics, and then smaller particles, which are called microplastics, and we include nanoplastics also. But let's go to the definition. According to the National Oceanic and Atmospheric Administration, microplastics are called all those artificial polymers smaller than 5 millimeters. So we can be talking about particles of few millimeters, but also we can be talking about particles of micrometers or nanometers, which of course are invisible. As you can see, in this case, some of those particles must be in can be seen with the microscope. Okay, the main thing is that unfortunately these particles are spread everywhere, and we know that only winds of just 0.4 kilometers per hour can make the particles of microplastic to penetrate into the atmosphere. That's a problem because
That's
just
very low, right? That's like a breeze.
that's a problem because 0.4 is practically nothing, and I will check something else in the computer, but 0.4 kilometers is practically nothing, and practically every microplastic particle that you have in the water surface or in the land surface will penetrate into the atmosphere.
That's incredible. And
Yeah.
do you know the and the distance they can travel or the altitude?
Yeah, that's under study, but they can travel very, very long distances. How long? We are talking about thousands and thousands of kilometers or miles, you know.
Yeah.
Another thing that I wanted to say is that unfortunately, we found this. I will go further with this later, but we found this on every corner of the planet. In my case, I found them on Antarctica. That's a part of this talk, and I want to show you the first results. Okay, let's see if we make an introduction of what are microplastics. We know that are artificial polymers smaller than 5 millimeters. Okay, we have many types of microplastic. For example, the most founded may be fragments and fibers, sometimes pellets also. Okay, if I think it's important to know that if we have to make a light classification of microplastic, we may have primary and secondary. That this is important to know, where do they come from? I mean, why do we have microplastics? And we have microplastic because of two reasons. Those called primary microplastics are because they come from production, massive production, of course, of products containing these particles. But there's another reason, those called secondary microplastics, which come from degradation of larger plastic objects. Okay, we have two main sources. But for example, we can give some examples. Let me go to the next slide. And for example, if we take those microplastic related with production of massive production, we may have, for example, cosmetics and personal hygienic products. That part of the industry, unfortunately, make an emission of microplastics everywhere. The problem is that it's a massive industry. Okay, then we have textile industry, we have wastewater treatment processes, and some others. If we go to the other reason of microplastic, of the presence of microplastics, like degradation of larger objects, of course, we have fragmentation of larger objects that you can find them in lakes, in ocean, in land, and they degrade. Degradation is because of sunlight, because of winds, and in the case of the oceans, because of waves also. Tire wear is another factor, and laundry. You can see
Tire wear
that.
is the wheels of the cars and all of that. That is tire wear. What is tire
Yeah,
wear? See,
exactly.
the cars.
The use of tires. Yeah, exactly. And can you see that there are two of them that are black? That
Highlighted, yes.
exactly. That's because we can see in the next slide that those two are the main sources of microplastic. Take a look
Wow.
at the first one, the textile industry. I forgot the word. The textile industry, which practically is responsible for more than 30% of overall microplastics in the world. I'm not talking about atmospheric microplastic. Every microplastic in the oceans, everywhere, in the animals,
I
inside
can't
us.
believe this. I had no idea. I would have never thought it would came from the textile industry. I'm so surprised.
Yes.
Yeah, yeah. And then tires, of course, that may make surprise you even more, maybe, Luciana, because the use of tires and the industry makes also a source of microplastic. But then you have dust, city dust. So this city dust is related with what I'm going to talk at the final, and is part of my study too.
Can I ask a question about the tires? Is
Yeah.
it the use of the tires, or is just the waste of the tires?
Well,
I mean,
I mean, by using them?
I will say the word in Spanish, desgaste.
yeah,
Wearing off, yes.
the wearing of the wheels as we use them in the world. Okay, if you think
Okay.
about it, everything has tires, even planes.
Yeah.
See?
Exactly. And take a look here to the general increase in the world of plastic production of all sectors, okay, and in all the world. The blue graph across the years shows you that there was an exponential increase in microplastic. That's the boom I said at the beginning a few decades ago, okay. Unfortunately, this increase is accelerating, and that's a concern. Let's take a look in this graph, which shows you just that it's important to know that increasing presence of microplastic in the world is the major source of pollution for all terrestrial or aquatic environments. These particles have been detected, unfortunately, as I already mentioned, everywhere, and the consequence this may have for human health, this is, of course, not my expertise, but I know that it is under study, and as you can guess, it's harmful, it's not good, but
Right.
it's still an issue which is under study.
Mhm.
Another point I wanted to highlight is that, unfortunately, it's not that microplastic remain in one sector. They just spread everywhere, and they make an exchange among different components of the climate system. But what do we call climate system? Because of this, you may think that climate system is only related with climate, and it is not. We call climate system practically to the whole planet. The climate system, when we say climate system, we mean the atmosphere, we mean also the oceans, we mean the cryosphere, glaciers, polar regions,
All the ice, yes.
ice, exactly. We mean land, lithosphere, and we mean the whole biosphere too. The biosphere too. So all these components make the climate system. Unfortunately, there's a large exchange. I mean, these all components interact between each other naturally. But if we put an amount of microplastic in one component of this climate system. Unfortunately, there will be an exchange in all the other components too. So, if we focus now in the second part of this talk, and we speak about atmospheric microplastics, which is more my expertise area, because microplastics, at least in Antarctica, in Antarctic Peninsula, were studied. I will show you that they were already studied in waters, in sediments, but microplastics in the atmosphere is a newer issue. You know, were not so studied, at least in our study region, which is Antarctic Peninsula. As you can see, there's a growing interest in studying the presence and the transport of the microplastics in the atmosphere. And just take a look. If you see in Google Scholar how many articles you may find across the years, you have 14 just 30 years ago, you have a little more in 2015, and many more in the last years. So
and that is only with those two keywords, atmospheric and microplastics?
Exactly.
Okay.
Exactly. As I told you, and I will show you a few examples of few publications, you have many others. Presence of microplastic in water, in sediments, in the stomach and of penguins, of many other animals, were already studied before. We saw that there were practically no studies about presence and transport in the air, airborne transport of microplastic in the Antarctic Peninsula. So that's why in 2022, we started a project with these people. One of them will be my PhD advisor, Dr. Gabriel Silvestre, but there are other members of this team which we started to analyze the presence of microplastic in an Argentine Antarctic station, where in Carlini Station, former Giovanni Station. It's a station located, as you can see, in 25 de Mayo or King George Island in the South Shetlands to the northwest of the Antarctic Peninsula. This is the southwest corner of the island, and if we take a look, we will see that close to the Potter Cove, we have the station, Carlini Station, and we put 3 points, site A, site B, site C, so to monitor the presence of microplastic in the air across the year. We started this in 2022, and we found the first results last year. So we made with all the team a publication that I will show you now, but this is the monitoring of microplastic in Carlini Station. Can you see that you have like 4 glasses collocated in each direction?
Yeah.
Exactly. Well, so of course, this instrument collects everything, but then through a chemical analysis with some colleagues, you can take what you want. And what we found last year was, let me show you.
But wait, that is a glass, that is a closed container with a tube. That was like a straw with a tube coming out.
Yes, and
let me go back.
Yes, yes. And the sample is taken, I mean, from the air that comes from inside the tube. Exactly.
You collect air particles of the air. You collect also water, snow, which in the spring may melt. You collect everything. You have, this is a passive sampling.
I was asking if it sucks or it's a passive thing. It just goes in, whatever gum goes by and fits into that hole, goes in.
Right. I couldn't hear you properly. Sorry, Luciana.
See, I was going to ask if that is a passive system. Basically, the only thing that you manage is the diameter of the orifice of what you want to go in. Okay.
Exactly. But take a look at the right, the smaller graph. Do you see the red house and we installed also an active sampler, which has a bomb that gets air inside and collect also different particles through the filters. So we have both kind of samplings, the passive and the active ones. Okay.
Okay, and in the just near the house, is that the antenna-like measurement, or the one that looks like a camera?
No, the active one is those that one that you can see to the right, yeah, which
Okay.
has a
Yes.
the smaller graphs to the right of the slide.
Okay.
This, as I told you, this monitoring network, which is which is still working, was installed by me, but also by these people. So it's a good time to thank them. Luis Villa, Alejandro Ulrich, they were, without them, we couldn't have made this. And also taking the samplers and the filters, the first year, which we made the publication, I will show you next, were done by Rosana and Mauro. So they were the first that continued the project on territory, you know.
Because they live there. I say that they never come back. They live in the station.
You know, a colleague of mine from the Sequinor of National University of La Plata, Dr. Lucas Rodriguez Pirani, found, for example, the first result last year, these fibers found in these points. So we of course we made our first results. This is our work, which was published last November. But also we want to study not only the chemical point of view of this issue, but also, in my case, as a climatologist, the atmospheric point of view of this. So we are working on the transport, the airborne microplastics that goes to the Antarctic Peninsula, coming, for example, from southern Argentina and Chile. For example, if we take a quick look on this graph, we can see main sources or main cities of Patagonia that may have an impact on transport of microplastics through not only Antarctic Peninsula, but also to the east. You know that contaminant sources in southern South America and also Oceania could have an impact through westerlies to the Antarctic continent, at least in the surrounding areas. Let me show, for example, what I did is to select 2 days, 2 different days, and if we see the upper graph, we can see, for example, we take Ushuaia, okay, the southernmost city of Argentina. If we take Ushuaia as a source point, we can see in the top to the left a trajectory of air masses going from Ushuaia to our study region, okay?
Yeah.
If we go to the top right, we will see the dispersion of pollution of particles that they origin in Ushuaia and they reach in few hours Antarctic Peninsula. Why this is produced? Because of atmospheric circulation, surface atmospheric circulations. Do you see in the middle at the top an H and an L? This is high pressure areas and low pressure areas. So these may produce an atmospheric surface circulation that favors the transport of these contaminants and others, of course, but we are studying and focusing on this from source points to other points. But the issue and the goal is also to identify when this happens and when does not. Because, for example, if we go to the below, the three graphs, but not at the top. Below, we can see another day when pollutants from Ushuaia didn't reach our region of study, which is South Shetland or Antarctic Peninsula. They were to the eastward. They had an eastward propagation. So, and this is because, of course, of atmospheric circulation. So, in my case, an atmospheric point of view is to study the atmospheric circulation related or associated to the transport of these contaminants that we already found in the South Shetland.
I have two questions on this. Yeah. One is if you know the altitude that it can reach in order to reach either the South Shetlands or another destination, and then
latitude or altitude?
Altitude.
Yeah.
And then the second question is, as I can see, so the stronger, if I'm seeing this well, the stronger winds would take the plastic go easterly instead of south.
I mean, the stronger winds in these regions are from the west. They are westerlies.
Exactly. So,
yeah, they will take these particles eastward. You know.
Exactly. Right. Yes. Okay. Good.
And for the answer to your first question, you may find it. Unfortunately, I think I cannot. This is an animation of dispersion of contaminants, but I cannot make this to play, unfortunately. But you will see the same thing that I showed you in the previous slide. Okay, in the right, top and below, in the right. But I wanted to show you the animation. And do you see in the middle a graph?
Yep.
This will show you the altitude of different colors. You have blue colors, black colors of the dispersion of pollutants, and the altitude of this dispersion of pollutants you may find in this model in the middle of the two graphs, right and left. Okay, the left is the case which the dispersion reached our region of study in Antarctic Peninsula, and the right is the case that it did not.
Yeah, it's 1,500 meters, more or less.
Yeah, and also even more. Also, maybe probably, you know, planetary lawyer is 1,000 meters, so it may reach the whole first lawyer, which turbulence may dominate.
Right.
Alpio, this is so interesting. I got desperate as your as your slides would go through the atmosphere, the lithosphere, and the hydrosphere and the cryosphere, because they're everywhere. But one of the things that actually you planted in my brain is there any way? Of course, it affects the biome. I can think of that in many ways. When I was young and I worked working with turtles and dolphins, I got to see microplastics and macroplastics in their stomachs. But do we know if they could interact with climate?
Yeah, that's a good question. You know that, I mean, I think there are not so many publications how these particles can affect weather and or climate. But for example, you know that clouds may form because of hygroscopic particles. They are solid particles, very, very, very small, but they are solid. You need this solid particle to make a cloud droplet. If not, if you do not have this hygroscopic particle, you need a temperature as low as -40 or -45 to make a cloud droplet. So we wouldn't have clouds without these hygroscopic particles. And if you have more aerosols in the air, you could consider microplastic in the proper size as aerosol particles. These eventually could favor the formation of clouds. But of course, this is something which is under study. But not only maybe affect cloud formation also may affect glacier melting, because you know that unfortunately, because of changes on climate, some glaciers and also some others, because of natural dynamics, some glaciers are melting, and if you have more aerosols or more solid particles in the glacier, this may accelerate the process of melting. This is, of course, another topic which is also under studies, and it's not my expertise at all.
No, but it's very interesting, and you made it pretty clear. It's such a great topic and such a hot topic, eh? Now, why are you laughing, Sebastian? You see my desperation face, or you're getting desperate?
Yes, well, both actually. Yeah, it's amazing that yeah, we can find plastics in the most pristine place in the world, and now in
in the atmosphere,
in brackets.
Of
No,
course,
not in brackets.
of course. Alpio, this is your PhD, part of your PhD dissertation, or?
It will probably be. It's under review. It's still under review, but it will probably be. So there are some things we have still to confirm and to define with my PhD advisor, Dr. Gabriel Silvestre. But it's an interesting issue because it's not a classical matter. It's not a classical issue. It's under study. So I think that's a lot of to do.
Absolutely, and I wish you so much luck. I hope we get updates from this, and thank you so much for sharing this with us. Thank you very much.
Oh, I thank you because of this invitation. Thank you very much.
Great. It's going to be later posted in our YouTube channel, so you can share and watch again. Thank you so much, Alpio. Great.
It was amazing.
And thank you for the listener. Thank you.
Our pleasure, always.
Thank you, guys.